Good morning, class. Welcome to week 2 of distance learning. So today we're going to learn our last factoring method, which is factoring a difference of squares. So what I'd like you to do right now is I want you to do the warm-up. I want you to expand each of the following sets of binomials and then simplify your answer. Okay, so pause the video, get that done. When you have finished, please resume the video. Okay, so when you are multiplying a plus 3 times a minus 3, you should have used the distributive property twice when you're expanding to get 4 terms like this. So you get a squared minus 3a plus 3a minus 9, because we're multiplying a times a for a squared, a times negative 3 to give us negative 3a, 3 times a is positive 3a, and 3 times negative 3 is negative 9. And when we simplify this, we get a squared minus 9. So you're doing the same thing for each of these questions, and then your final answers were 9x squared minus 16 and 4x squared minus 25. So I'm going to write down those final answers on the lesson sheet. So when we expand, the final answer again was a squared minus 9. This final answer was 9x squared minus 16. And this final answer was 4x squared minus 25. Okay, so again, you can, if you missed something, you can rewind the video or you can refer to the PDF of the note. So B said to examine each question and answer, what similarities or patterns did you notice? If you haven't already answered this, pause the video and think about those answers, and then do C as well. So what you should have noticed is that in the questions, the two binomials are exactly the same. The only differences are the signs in between them. Okay, they have opposite signs. And we can see that they always multiplied to a pattern where we have the first term squared minus that second term squared in each of them. So that allows us to quickly multiply something that's in the form of x plus y times x minus y. I know from the patterns above that I will always have that first term squared, and then it's going to be minus the last term squared, because in our work the two middle terms always canceled out. So here, when we multiplied it out, doing the distributive property twice, those two middle terms always became a 0. They canceled out in each of those examples. So today's lesson, we're going to factor a difference of squares. That's a difference of squares. It's a perfect square minus a perfect square. When we subtract values, the answer to a subtraction statement is a difference. So that's where that word's coming from. So we're going to list all perfect squares from 1 to 225. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Okay, pause the video and keep going, and then resume. Now we're on 4 squared, which is 16, and then I'm going to keep going. So you should have had the numbers 25, 36, 49. I'm on 8 squared, which is 64, 81, which is 9 squared, then it's 100, 11 squared is 121, 144 is 12 squared, 13 squared is 169, 14 squared is 196, and then we're going to go up to 15 squared, which is the 225. So these are very helpful numbers to know and recognize in order to do difference of squares factoring. Excuse me. Okay, so now we're going to make a list of variables that are perfect squares, which have x as a base. So let me start you off. So the first one is x squared, because x times x is equal to x squared. So what would the next one be? Well, the next one is x to the 4th, because x squared times x squared is x to the 4th. I'm going to add those exponents. 2 plus 2 gives me the 4th. And here when I add the exponents, the 1 plus 1 gives me the 2. Okay, so again, what's the next one? It would be x to the 6th, because x cubed times x cubed is equal to x to the 6. I add the exponents when I'm multiplying powers with the same base. And then the one after that would be x to the 8th, because x to the 4th times x to the 4th is x to the 8th. Okay, and that pattern continues. So notice that we always have an even exponent. So variables that are perfect squares that have x as base, they will always have even number exponents if it's a perfect square. So using the patterns we recognize from the warm-up, how can we quickly factor any difference of squares, which is an expression that's in the form of x squared minus y squared? Well, that's easy. So if it's in the form of x squared minus y squared, like each of these final answers, if we look back to what the question looked like in each case, we got, there's two brackets, there's a plus sign in the middle of one, a minus sign in the middle of the other. The square root of the first term went in this position. Okay, the square root of a squared was a. And the square root of that second term goes in the second position. So again, the square root of 9 is 3, goes in the second position. And that's it. That's how we're going to factor a difference of squares. So let's go through some examples. Okay, so in the first example we have 49x squared minus 81. Now if you take a look at our list of perfect squares, the 49 was on that list, so is the 81. It's separated by a minus sign. X squared is also a perfect square. So when we recognize that pattern, we're going to draw two brackets. We put a plus sign in the middle of one, a minus sign in the middle of the other. We take the square root of the first term. So the square root of 49x squared is 7x. We put it in that first position. And then we take the square root of the second term. The square root of 81 is 9. It goes in the second position. Okay, it is factored. So remember, to factor an expression means to write as a product. It's written as a product. We are done. In the second question, this is also a difference of squares because 169 is a perfect square, 225y squared is a perfect square, and it's separated by a minus sign. So I'm going to use difference of squares factoring. I'm going to draw two brackets, put a plus sign in the middle of one, a minus sign in the middle of the other. The square root of the first term, which is the square root of 169, is 13, goes in the first spot. And the square root of 225y squared is 15y, so it goes in that second spot. We're going to do some questions that look a little bit more challenging. So example 2 says to factor. Now, this is also a difference of squares because x plus 7 squared is a perfect square. It's the answer, or if I take the square root of x plus 7 squared, I get x plus 7. And 4 is a perfect square. And then it's separated by a minus sign. So I know again that whenever I'm factoring a difference of squares, I'm going to draw two brackets. This time I'm going to draw the brackets a little bit bigger. A plus sign is going to go in the middle of one. Well, not quite in the middle in this question. And a minus sign is going to go in the middle of the other. Okay, so again, what's the square root of x plus 7 squared? Well, it's x plus 7 because x plus 7 times x plus 7 would give me x plus 7 squared. If you want to put that in brackets, you can. So I put in the first spot. And then we're taking the square root of 4, which is 2. Okay, so we started by, we factored the difference of squares. And then the next step is we're going to simplify. So I'm just going to add like terms within each bracket. So x plus 7 plus 2 would give me x plus 9. And then in this bracket I have x plus 7 minus 2. 7 minus 2 is 5, so it's x plus 5. So here in the first step, let me just jot down what we did. Here we factor the difference of squares. And in the second step, we simplify. Okay, B is a similar question. So here's a perfect square. We've got a minus sign. 2x plus 3 squared is also a perfect square. Now, in this question, we're going to have to be a little bit more careful because of this minus sign, which is in front of the brackets. So just bear that in mind. So when you see a minus sign in front of a bracket, let's always put that star on top of it so that we remind ourselves to be careful. Okay, so again, 2 brackets. I need bigger brackets. I'm going to put a plus sign in one, a minus sign in the middle of the other. I take the square root of the first term and I'm going to put it here in the first position. And the square root of the second term, which is 2x plus 3 squared, is just the 2x plus 3. Now, I could put brackets here. It doesn't matter so much because of the plus sign, but I absolutely have to put brackets in this spot because of the minus sign here. The minus sign over here, when I simplify, I'm going to have to use a distributive property, which is going to change the signs. So this is imperative. Very, very important. So you must add the brackets. Okay, now we're going to start simplifying. So we have 6 plus 2x plus 3. I'm going to add like terms. So now I have 2x plus 9 in the first bracket. In the second bracket, I'm going to distribute out the invisible negative 1. So the signs are going to change. So I have 6 minus 2x minus 3. And now I'm going to add like terms. So I have that negative 2x by itself. 6 minus 3 is positive 3. Now some of you might look at this and you might think that looks a little bit funny because my leading coefficient in this bracket is a negative. So if you recognize that, it's nice to factor out the invisible negative 1 from this bracket. I'm going to put in front of the whole thing. Okay, so again, it's an invisible negative 1. I could write down the 1 or I could just put down the negative. So it's 2x plus 9. When I divide each of these terms by the negative 1, the signs are going to change. So I've got 2x minus 3 as my final answer there. I wrote down a little tip for these questions for you. So don't start by expanding. You want to start by factoring instead because it does have a difference of squares pattern. And then after you factor the difference of squares, you want to start simplifying. Okay, so again in this question, the first step was we factor the difference of squares. And all these steps in here, this was all part of the simplifying. Okay, we're going to do some questions on the back now. Okay, so example 3 says to factor, and A says 18x squared minus 32. Now, this is not a difference of squares. However, it is a binomial, and you might think it kind of looks like a difference of squares, but it isn't because 18 is not a perfect square, and either is 32. But what we can do is we can factor. So let's start by common factoring. What's the greatest common factor in this question? We can factor out a 2. So let's do that. So when we factor out a 2, we're left with 9x squared minus 16. Now let's take a look at what's in the brackets. What we have in the brackets, what's left, is a perfect square. Or sorry, they're 2 perfect squares separated by the minus sign, so they are a difference of squares. So now we're going to factor that difference of squares. So I draw my 2 brackets, plus sign goes in the middle of one, minus in the middle of the other. Square root of the first term goes here, and the square root of the second term goes there. This is now factored fully. Okay, so let's write down what we did. We started by we common factored as our first step, and then here we factor the difference of squares. Let's try the next one. So right now it does not look like a difference of squares factoring pattern, but we take a look and we see if we can common factor. What's the largest common factor that goes into 12y squared and then 3 or the negative 3? The answer is 3. So I'm going to factor out a 3 and I'm left with 4y squared minus 1. This is a difference of squares. So I'm going to factor again. Draw my 2 brackets, put a plus sign in one, a minus sign in the other. Square root of this first term goes here, and the square root of the second term goes there. It is now factored fully. Let's do that one more time. So I can't factor a difference of squares at the moment because it's not a perfect square minus a perfect square. So then I look to see if I can common factor first. In reality, we're going to learn this in our next lesson. You always want to start by looking for common factoring first. So that really is the first step in factoring. So what's the greatest common factor with the 9a cubed minus 49a? The greatest common factor is an a. I'm going to factor out the a, so I divide each of these terms by a, and I'm left with 9a squared minus 49. Here's a difference of squares, so I factor again. This factors to 3a plus 7, and in my second bracket I have 3a minus 7. It is now factored fully. So a couple key points to remember when you've got this factoring where you're doing more than one step. Don't forget to write down that common factor in every line. If you don't do that, when you end up expanding your answer, you would never get the original question. Okay, that's it for this lesson.